Welcome to the CAMWorks webinar for creating custom tools. The following video will illustrate the process to create a custom mill tool and custom turn tool. Referring to the part model displayed, we will create a custom mill tool that will be used to machine the whole feature. We can view the different levels of contours and feature shapes of the whole feature that will help define the custom tool. In this example, we will be referring to the upper segment of the whole feature. We will create a custom tool that matches this part for the part feature. We can utilize the SolidWorks sketch that defines the whole feature to define the custom tool. This is accomplished by copying and then editing the sketch from the part model. We will copy the sketch from the part model, then create a new SolidWorks part. From here, we can paste the copied sketch into the new sketch within the SolidWorks feature tree. Once we have the new sketch established, we can make edits that represent the intended tool geometry. First, we will shorten the overall length by adding a line segment and then deleting the unnecessary line segments. We do not need the long, narrow section of this drawing. Ensure that the edits made still create a closed sketch. Now we need to position the sketch in the appropriate orientation. The sketch must reside in the upper right quadrant relative to the SolidWorks origin point. This can be accomplished by utilizing the SolidWorks functions rotate and move. The intent of the rotation is to make the X and Y values positive. Now that it's rotated, we can go ahead and move it to the origin point. Again, note that the sketch is within the upper right quadrant of the Cartesian plane, and this is going to be critical. Once we are satisfied with the initial tool sketch, we can start adding key dimensions to the sketch. These values will be needed when defining the tool in the CAMWorks technology database. The important values are the overall flute length and the tool diameter. In this case, the tool diameter will be represented by the radius. In this case, it would be 375 thou. Now that the cutting portion of the tool has been defined in the sketch, we can build an additional modification into the sketch, which includes defining the tool shoulder length. This modification allows for the overall length to be dimensioned, which we will define as a 2.5 inch long segment. This is another key value used in the CAMWorks definition dialog in the technology database. We will delete the top line segment and then add additional line segments to represent the tool shoulder. Remember to ensure that the sketch is closed. Here we will dimension the length and set that to 2.5 inches. Once the sketch is complete, we can create the solid model by utilizing SolidWorks Revolve Sketch. We will revolve around the line segment that goes through the origin point. We can add appearances to the model to help illustrate the distinct sections of the tool, such as the shoulder and the cutting flute. However, these appearances do not appear in the CAMWorks model, only the SolidWorks model. At this point, we can save the model as a SOLIDWORKS part file. CAMWorks has a default file location for custom tools, but these files can also be saved in any desired location. For this model, we are using the default folder location, which is at the C drive /CAMWorks data /CAMWorks 2012 /tooling /mtools. Notice that there is also a folder for the custom mill tool holder. Enter a desired file name and save the SOLIDWORKS part file. Now that we have created and saved a SOLIDWORKS model that represents the custom tool, we will need to save the model as a CAMWorks part, which uses the file extension .mt. From the menu bar under CAMWorks, select the option User-Defined Tools and Holders. From this dialog window, we will select the option for Mill Tool. By selecting the Browser button, we can choose the save location, which in this case is in the same folder that we saved the SOLIDWORKS part file. We can either create a new file name for the CAMWorks part, or we can keep the same file name used for the SOLIDWORKS part. To make it consistent, we will use the same file name as a SOLIDWORKS part file. The next set of steps will be to define a custom tool in the CAMWorks technology database. Open the technology database and select the tooling button. Then select the form cutters button and the user defined tools button. We will insert the custom tool at the last entry point of the list. Scrolling to the bottom, we will see the row that has an asterisk in the far left column. Clicking on the shaded box adds a check marks to the box and activates the row for edits. Start by giving the tool an ID description. Using the values from the dimensioned model, we will populate the appropriate boxes to define the attributes of the custom tool. We will start by entering the cutter diameter, which is 750, and the shank diameter, which is the same. We can then add the flute length, which is also 750 thou, and then insert the overall length, which is 2.5 inches. We can leave the protrusion value as it is. We will also select the hand of cut and tool material. Add additional comments for the tool as desired, which will help define the tool. Now we can point to the CAMWorks model file that represents this tool. We will select the file from the folder list. We can now back out of the technology database and refer back to the model. The model we have has pre-existing operations that machine the smaller hole diameter of the feature, which goes through the part. The intent is to utilize the existing feature definition for the custom tool by inserting a new hole machining operation for a drill. From the CAMWorks operation tree, right-click on the mill part setup and select Insert Hole Machining Operation, and then select Drill. Select the hole feature that is listed in the feature window and select OK. We will then edit the operation and select the custom tool that we just built. The default tool is being used as a part holder for CAMWorks. Selecting the desired tool is done by adding the tool from the user-defined tool library to our current tool crib. Once the custom tool has been added to our tool crib, we can then assign it to the operation. Once we hit select, we can see that the preview shows our custom tool. Next, we need to define the machining depth. In this case, it will be equal to the tool's flute length. This is done at the Feature Options tab. Click on the icon to the right of the shaded box for the machining depth. This allows you to enter a value, in this case 750 thou. When we preview the operation and step through the toolpath, we can confirm the proper machining depth. The origin point of the sketch when we built the tool is now the driving point of the tool. And now we can run through a toolpath simulation for all of the associated operations and watch the whole feature be created. We can also do a section view once this is complete to see the actual profile created by the custom tool. Now let's create a custom turn tool insert. The model shown already has CAM data. We will edit a bore operation so that it will utilize a custom turn tool. In this case, we will apply the custom turn tool to the rough bore operation. For time management, the desired turn insert has already been defined in a SOLIDWORKS sketch part. We use the same quadrant location as we did when creating a custom mill tool. Note the origin of the sketch. This will be the drive point for the insert. For a turn insert, we will extrude the sketch using SOLIDWORKS extrude function rather than revolve. The extrude direction in this case is below the origin point, and the extruded value represents the insert thickness, which is a key dimension to remember when establishing the technology database inputs. As with the mill tool, we will save the SOLIDWORKS part file for the turn insert. For this exercise, we will use a user-defined folder location rather than the CAMWorks default folder. The turn tool insert file extension is .cwtt. We will now define the tool assembly in the CAMWorks technology database. We'll go back to the part and we'll open the TechDB from here. We'll start by defining the insert. Select the tooling button, then the turn tooling button, and then the insert button. And from there, select the user defined button. Here's where we will insert the thickness of the insert and enter any comments and descriptions that help define the custom turn tool. As with the custom mill tool, we will need to point to the file for the custom insert. Once you click the open, ensure that the field is populated with the correct file. Now we want to define the holder that is used for this insert. In this case, a boring bar holder will be used. An existing defined holder can be used, or you can create a new holder by entering the desired values. We will select a user-defined boring bar holder that is already created. Then, going to the turn tool assemblies, we will now build the turn tool. Start by selecting the insert type, in this case user-defined. Then select the insert. When you click close, ensure that the insert description has populated the field. Now choose the holder type, which is a boring bar, and select the desired boring bar holder. Again, ensure that the holder description has populated the field after clicking OK. We can add comments to help describe the new turn tool and to help find it within the list after completing the definition process. When finished, make sure that you click the pencil icon, and that confirms a completed inserted information, and click OK. We can now back out of the technology database and go back to the part file. From the CAMWorks operation tree, we will open the operation definition for the rough bore operation. From here, we will add the custom turn tool to our tool crib and select it for the rough bore operation. Here we're adding the turn tool, and it's going to look into the default library. This is where adding specific tool comments becomes helpful. The turning tool list is not in any defined or sorted format. It may take a while to find the tool that you have created, so look for key comments and key parameters. You can select and highlight it and hit OK, which will populate our tool crib. And from there we can select the inserted custom turn tool. The message concerning the holder orientation is CAMWorks' way of letting you know the holder's original orientation is incorrect for this operation, and that it will adjust it accordingly. Click OK on the message window. When we first view the custom turn tool, the insert is embedded into the holder. We can adjust this by changing the X and Z values. Watch the movement of the insert as these values are edited. These settings will help avoid holder collisions. Create a setting that represents your tooling. Other key settings to verify are the hand of cut and holder edge. Now let's step through the operations toolpath using the newly defined turn tool. While we step through the toolpath, we can observe any potential interference or other concerns related to the tool description, such as tool holder clearance, as well as the turn tool insert length or protrusion. We can also run the toolpath simulation to view any gouges or excess material. This completes our webinar on custom tool creation for CAMWorks. Thank you for joining us.